welcome back, and today we're back to working on the Centurion, most notably this big beast back here. This is my Data 100 made chain printer. It has a chain with all of the characters on it that spins at a relatively high speed, and then it has a bunch of hammers that slam into the chain at the precise right moment to imprint a character onto the paper. And it's pretty impressive. It'll do 125 lines per minute with 132 characters per line across 14-inch wide tractor feed paper. It makes a glorious racket and it sends paper out the top at a pretty prodigious rate. It's a lot of fun. And in the previous episode, we got it really close to fully working. We actually managed to have an entire test page print out with no errors. That's pretty awesome. It prints 132 dollar signs per line forever. And we had a couple of problems that seemed to kind of work themselves out, but we still have a couple problems lurking underneath. The biggest, most scary one is that this thing doesn't actually have 132 hammers in it. It only has 66 hammers. So the carriage has to move left to right, and that left to right movement didn't seem to be all that healthy. Another problem that we have is that the ribbon is very weak, and that's actually not unexpected. This printer's pretty old and that ribbon has a finite lifespan, so it's probably out of ink. And you guys left a ton of excellent comments about how to try and re-ink that ribbon, so that's another thing that we're going to try and take a swing at today. But the big thing that we're going to do, if we get everything else to a point where we're moderately happy with it, is we want to get this connected up to this, because printing just dollar signs is pretty boring. I want to print actual real text, and the Centurion has some pretty epic stuff, test programs to do that. In order to do that though, we need two things. We need a controller card. Hey, look at that. We got a controller card. And we need something to connect the controller card here to the printer itself. Look at that. It's a cable. So we have all the pieces here. All we got to do is start plugging stuff in and flipping switches and see what happens. So today is going to be pretty epic. I'm really stoked for it. And oh man, well, let's just hop to it. I've got the printer out and I've got the covers off of it, the main large cover as well as the card cover that goes over all of the cards here in the back. And those need a proper cleanup, and I'm gonna get to that, but I am like way too impatient to do that now. Same with the ribbon re-inking. That's gonna be an endeavor to try and get some ink back into that ribbon, and I just can't wait. I gotta plug this thing into the Centurion to see what happens, see if we can get some proper test prints out of it. But we had a strange problem lurking in the previous episode, and that has to do with how it actually hammers the characters onto the paper. This is 132 columns wide, but there's only 66 hammers. That means that each hammer is doing double duty. So the hammers are all mounted to a carriage that rotates left to right. It just moves left and right and does 66 columns and then moves and does the next 66 columns. Then it feeds the paper one line, and the whole system just keeps going forever like that. So you end up with this interesting ballet of left, right, feed, left, right, feed, left, right, feed over and over. But we were having trouble with that left to right motion not working right. It was jittering and stuttering and kind of falling back to the center location. But as I ran it in the previous episode, while I was filming B-roll after I had done all of the primary filming, that motion seemed to be getting a little better. And by the time I had finished B-roll filming, that motion was exactly how it was supposed to be, and we were getting clean prints out of it. So I think what happened there is that left to right motion of the hammers is done by the 30 volts DC rail. And there's a big smoothing cap on that DC rail that I think is underneath this panel here. And I didn't reform these capacitors because they weren't on the power supply, and I didn't know. But I think they've reformed themselves because it seems to be working pretty good. So we'll flip the power switch on here. There we go, it fed the ribbon a little bit. The chain has spun up. I'll flip the test switch here. And you can see the carriage is moving back and forth exactly like it's supposed to. And the color is still weak because we gotta re-ink that ribbon, but we are getting prints out of it. That's excellent news. So it's so loud. It's so loud. So I think we're good to go with plugging it into the Centurion and trying to get it to print fully out of it. This is really exciting. So let's plug the printer card here into it. This is a really interesting card, extremely simple. I actually reverse engineered this card and have the full schematic for it. It was the first thing I'd ever reverse engineered and the first schematic I've ever written. Don't go too hard on me with how it looks. I know that it's all organized poorly, but we actually have it. It's just a simple MMIO card with a Centronics interface. So let's plug this in, plug the cable into this, spin the hawk drive up, and see if we can get some interesting prints out of it. First things first, let's pull the cover panel off, giving access to the computer cards and a backplane. Then I'll slide the diag card out. It wasn't actually plugged in, it was just hanging out. And then I'll slot the printer card in, seating it fully in the backplane. Next, I'll plug the cable into the edge connector on the printer card, and then plug the other end into the Centronics parallel port on the back of the printer. I love these little locking clasps. I wish more connectors had these. Then we just turn the data terminal on, flip the main power switch to power the computer up, and finally spin up the hawk drive. Once fully booted, let's do a quick .sta for a status check, and yeah, that all looks excellent. Okay, the Centurion is fully booted. We're into the operating system here. It's only showing 3 drives because I haven't powered the Finch up. It's just powered off. And actually the floppy doesn't even work either because the termination's on the Finch. So really, we don't care about the floppy or Finch with this anyways. What I want to check within the operating system is that the operating system has been ginned for this printer. So to do that, we need to go into the sysgen utility. Okay, to get to the sysgen utility, we do p.sysgen. It's not in a library. The file name is etosn. The disk number is 1. There we go. Okay, so we want to go to number 5, printers and spoolers. And yeah, there we go. P13 ODEC Smart PRT0. So this operating system has already been set up specifically for that printer. Makes sense, that printer came with this machine, so it would have already been set up for that. To get out of this, we do Control B for new line, 9, end of program. And we're back up to the main page here. To test the printer, we actually have a dedicated test for it. It's in the question mark folder. So if I do .dir question mark .1, this shows us the contents of the question mark folder, and we can see that we have a little ASCII file in here called test. So we'll hit Control C to quit out of that, and we'll do question mark .test. There we go. We've got a CRT test, a printer test, a mainframe test, and exit. We are most interested in the printer test, so we'll hit 2 for printer test. The printer name is PRT0. And we have some options here. We can do line feed, vertical tab, but the ASCII barbell pull pattern for 132 columns I think is going to be the most interesting. So we'll do number 2 here. And we got ATT and print. That's because I forgot to turn the printer on. All right, we'll flip the power switch on back here. The light came on. So we'll do ASCII barber pull pattern, 132 column. Oh, okay. Deselected or yoke/VFU gate open. All right, turns out I'm just not that smart. I gotta actually take the printer online, and that's done with this button right here. It says print. It's really hard to read. It's like the text is faded out, but print should put it online. So if I push print here, well, we should get a light on here, but I'm pretty sure the light's all burned out. But that should have put it online. So I've reset my print program up here. Let's try it again. Print. Whoa, whoa. It's printing. Yes. Well, that worked epically. Absolutely stunning. I've got about 10 pages of barbershop pull pattern here. How awesome is that? It just chews through paper, but it printed page after page with no errors at all. It is printing 100% perfectly. That printer is fixed. The only things that we have to do now is we have to get the tops cleaned up, and I want to try and get it to print a little darker. So I've got the ribbon right here, and I'm gonna try and re-ink it. And you guys had a ton of suggestions, but I wanted to experiment a little with this. So I've got a stamp pad here with some refill ink for it, and I've got a little foam roller. This is about $8 worth of supplies here. So what I'm gonna do, I think, is get the stamp pad with some ink in it, roll that onto the roller, and then just slowly work my way across the entire length of the ribbon. And that should impregnate some new ink into the ribbon. I don't know how stamp ink will work on a printer ribbon, but hey, let's find out. I'm gonna try and do just a short section first, and then load it up into the printer with that short section in the middle of it, and print and see how it looks. And if it looks great, then we'll keep doing it and do the whole ribbon. To work the ink into the ribbon, I just laid the ribbon across the stamp pad and used the foam roller to push the ribbon into the pad. In hindsight, the pad is not nearly as wet as I thought it would be, so it took quite a lot of work to actually get the ink to work into the ribbon. I think a rubber roller instead of a foam roller would have made a huge difference, but I'm in the middle of it already, so let's load the ribbon into the printer and give a little test print to see if it made a difference. And yeah, you can see that as the re-inked part of the ribbon gets fed across, the characters that are printed are so much darker. I think this crazy idea might actually work. To finish re-inking the rest of the ribbon, all 150 feet or 45 meters of it, I decided to leave the ribbon on the machine. This helped keep everything aligned and made it way easier to ink, advance, and so on. I did go through and supplement the ink on the ink pad about 5 times during the process. I don't know how necessary this was, but I do think it made the re-inking process a little faster. Ultimately though, it still took about 2 hours to get it all done, so I just put on some Volta and rocked out to some excellent dark synthwave. Now that the ribbon is re-inked, let's get to work cleaning up the rest of the system. And I'll start by removing the 4 nuts and then pulling the paper guide in the hood off. The paper chute that the printed paper exits through is held on by 7 nuts. With all 7 loose, it pulls right off, giving much better access to it and the inside of the hood. Next, I wanted to get the front panel off, and it's held on with 8 nuts, 4 per side. However, with all 8 removed, it still didn't want to let go. I fought it for a bit and then gave up. Figured if it wants to come off, it'll do it on its own. So instead, I taped off the clear acrylic so I wouldn't damage it while trying to remove the old foam. Then I pulled out the drill with a stripper wheel on it and got to work removing the large pieces of the old sound deadening foam. Also, that front panel decided it was time to come off after all, so that made it way easier to get in there and strip more of the sound deadening off. After all the big chunks had been violently removed, I pulled out the razor blade and really went to town. The metal was a bit corroded under the paint, which resulted in a lot of paint stripping off. And yes, I realize that this metal hood needs to be stripped back completely, hit with rust converter, primered, sanded, and then fully resprayed. But I ain't gonna do all that right now. So instead, I'm just going to lay down new sound deadening material. This is a butyl type sound deadening that is often used on cars, and I find it works really well. It's easy to work with and sticks to just about anything. And after a bit of work, the inside of the hood is looking fantastic and should be much quieter. Next up, I'll give the card cage cover a good wipe down, and then I'll try to remove some of the corrosion from what I believe is bird poop off of the top. Poop is very corrosive, so not only is the paint stained, it's also chewed completely away in spots. I got it a lot cleaner, but it's still not great. This is going back to that strip, rust convert, primer, and paint thing, and again, not happening today. With it clean enough, it's time to set the hood back onto the printer itself, and finally slide in the pins to connect the hinges to each other. Now that everything's all hooked up, let's do some test prints. I've got it in its finalized positions, so let's make sure that everything still works. And what better way to do that than with the most requested file ever. A couple episodes back, I was looking through a platter that I got from Butler Tech off of the CPU5 system, and there was a file in there called Girl82, and I got hundreds of comments asking what that was. So I've transferred that file over to this system. We can take a look at it by doing s.crt and then Girl82 on disk 1. that is not in the library. And look at that. Okay, so we got January, Sunday, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. Looks like it's going to be a calendar with a lot of exclamation points in it. Okay, so let's print this. I'm pretty sure calendars needed to be printed out. So in order to print it, we do s.lst girl 82 on 1, and we want to put that to PRT 0. Now all I got to do is hit enter, and it should start printing. Here goes nothing. Yeah, it's printing. It sounds very strange, but it looks to be printing correctly. That's awesome. It's so much quieter now that I have all the sound deadening in there. The actual Centurion itself is louder than the printer, but I'll put the microphone close to it so you guys can hear what it actually sounds like. Well, what did we print? Well, it's 3 pages. We can see it says 1982 down here, and we have a calendar along the right side. So it's a 1982 calendar. And if we open up all 3 pages, yeah, I can't show that on YouTube at all. I will get demonetized. It's exactly what it sounds like. Girl 82 is ASCII art. I can't show that. What am I doing? But we do have another file called cal82, and that one is not ASCII art. So we'll go ahead and print it out, and I think that one I can actually hang up in the room somewhere. Well, that finished printing absolutely beautifully. If I open it up here, it's a few more pages than the previous one, but this one's safe for work. You can see we have a gorgeous ASCII art rendition of Snoopy here that says, "Curse you, Red Baron," and it's followed by a giant 1982 in ASCII art, and then a 1982 calendar below that. And right here on the very bottom, it says, "Compliments of Cincinnati Data Systems." So this file, along with the Girl 82 file that we can't show, were both found on the removable platter from the CPU5 desk system that is at Butler Tech. That means that machine spent its whole life in Cincinnati. And now, 40 years later, we are finding files on there and printing them out with original Centurion tech. This is so cool. The printer is 100% working. It printed out 10 pages just now without even thinking about it. And I've gone through probably about another 30 pages printing out just test prints to see how things went. The re-ink of the ribbon is amazing. I don't know how long that stamp ink is gonna last. It may dry out and be useless in 2 weeks, but for now, the printouts are nice and dark and look amazing. And mechanically, the thing is working perfectly. The only things left that we need to do is maybe a little bit of stripping and repainting. We have some nastiness here on the top that went through the paint, but I mean, we can see that there's rust growing on the corners and on the blue bit down here. We also need to create a new label for the front here because the original Centurion logo here has faded away. But I've got a member of the Patreon that I'm going to work pretty closely with that can print me out a new one of those in vinyl so I can stick it on. And I may print out a second one to stick onto the Regent 200 terminal over there. But this is a fully working system. Right now, in its current state, it has a functioning Hawk drive, a functioning Finch drive, a functioning 8-inch floppy drive, a functioning Data 100 printer, a functioning Regent 100 terminal on top, and almost a completely stacked out card cage. In order for this to happen, so much stuff had to go right, and it all went right. This is amazing. But we're not quite done yet, because you'll notice that there is a large cabinet sitting right next to me over here. So we're 2/3 of the way there, but we still have this cabinet to deal with. Now in this cabinet, right on top, we've got the EDS PC, and it's pretty much complete. So we're gonna get to work on it next. Below that, we have a Phoenix drive and another Hawk drive. This other Hawk drive is really interesting because it has a different type of head, so I want to do some comparisons between the two, see how the operating system handles the different type of erase head on those heads. So we've got a lot more science and fun to do with the Centurion, but man, 2 years ago, 3 years ago, who would have thought? This was junk in a warehouse in Oklahoma, and now absolutely stunning. Oh, I'm so excited. Well, I want to thank you guys so much for watching. I'm going to print out some more stuff because it's so much fun just to see this thing go, and I hope to see you in the next episode.